Okay, in these slides, I want to kind of give an idea how to solve problems in general, and also if you get a bad grade in a midterm, how to evaluate or understand or try to find out why you got a bad grade so that you can improve in the next exam. So it's a very important thing to follow this material closely. So I'll just give an example. This is a problem. This is the given in the problem, and this is the drawing that's given in the problem. And they give you, it's a multiple choice problem, so they give you 5 choices, and the answer, we know it's going to be answer A, but we want to just show how to solve the problem in a systematic way, so that you can guarantee to make the least number of mistakes as much as possible. So the first thing to do in any problem is to draw the problem again yourself. Even if the problem is simple like this one, this problem is very easy, the drawing is very easy, but still draw it again yourself. Make your own sketch of the problem. And put all the variables you got in the problem, in the given, on the drawing. For instance, here you have Q is -4 nanocoulombs. There, you take it from here, you put it there. Every piece of information you see in the problem, put it on the drawing. This is basically a very important first step. Sometimes the drawing is very easy, so it gives you familiarity. When you draw the problem again, it gives you familiarity with the problem and what it's asking and what's the given. It makes things more familiar to you in your mind. So this is very important. The second thing is to categorize the problem. So to relate it to the theoretical material of the course, this problem, how do I categorize it? Basically, it's giving 2 charges, and it's asking for the magnitude of the electric field at point P. So this is the required. So basically, it's related to the part in the course where you're given a group of charges, and you want to find the total electric field vector, or in this case, the magnitude at a particular point. This is the big characterization of the problem, what the problem is dealing with. So this is the important thing. Then make a step-by-step plan how to solve the problem. So for instance, the first thing you will do is what? You'll use the formula for the electric field of a point charge to get the electric field due to each charge. So this is the electric field due to the big Q charge. This is the electric field due to the small q charge. And this will represent then the total electric field vector in the problem. So you get each electric field due to each charge first, and then you use the superposition principle to get the total electric field, which means you add the electric field due to each charge. And then once you get the electric field vector, you can then take its magnitude to get the total electric field, the magnitude of the electric field. So this is the step-by-step plan. You have to have a plan when you solve a problem. Sometimes when problems are easy, the plan is very clear, so you don't need to write it out explicitly, but it's a good practice to make a plan, write it out, so that you can see if you make a mistake, where your mistake was. So then start implementing the plan. So here they get the magnitude of the electric field due to the big charge, the big Q charge, and then they get the electric field as a vector. And here they get the magnitude of the electric field due to the small q charge, and then the electric field as a vector. So this is basically the first step. And then the second step, once I have now the electric field as a vector for each charge, then we basically use the superposition principle, which says you add these electric field vectors to get the total electric field vector. And then the last thing, once you have the total electric field vector, you take the magnitude to get the magnitude of the electric field. So this is basically implementing what we did, what were the steps that we said we wanted to do. But even at this point, it's important to note that it's very important to keep everything in symbols. Never substitute numbers in the beginning. If you go to this step and you start substituting numbers, it'll be a disaster, because when you make simplifications, maybe in this problem it won't be that big of a problem, but in many problems, if you substitute numbers from the beginning, you'll really get into a difficulty trying to find the error. If you get an error in the problem, trying to find the error will be very difficult. So what you do is you keep everything in symbols until the last step. So we'll show in the next slide how to simplify this and when to use the calculator and when to substitute numbers. So here I put the answer from the previous slide, and these are the values of KE and A and B and Q, big Q and small q. At this point, it's important to simplify a little bit before substituting the numbers. So do the square. So here they did the square, and then you notice that you have KE squared and KE squared. When you take it out as a common factor, you get KE. So that's a nice simplification. And then even at this step, you're going to substitute numbers, right? But you're not going to use the calculator straight away. So here at this step, you substitute value of Q, big Q and small q, and A and B, that's fine. But still at this step, don't use the calculator. Why? Because you can first do the square. You can take the 10 to the power minus 9 outside of the square root. And then there's the 4 squared. There's the 0.8 to the power 4, there's the 1.5 squared, there's the 0.6 to the power 4. You notice that here 10 to the 9 and 10 to the minus 9 cancel. So you just get 9. So that's why I'm saying at this step, don't use the calculator straight away, because if you use the calculator, you'll be calculating things that are really not necessary. You need to get it into the simplest form where you cannot make anything simpler. Then you start using the calculator. And in this case, this seems to be the step where everything is simple enough so you can start substituting, start using the calculator. You have easy numbers, you have everything in a nice, easy way. So, and when you have all these steps written down on a piece of paper, you can always go back and check where the error, if you got an error, where the error was. But if you substitute with numbers from the very beginning, it'll be very difficult to find where the mistake was. So at this point, you use the calculator and you substitute, you get this value, which is one of the solutions as was given in the beginning of the problem. So this is step-by-step systematic way of solving problems. Sometimes in some problems, they give you the answers, the multiple choice answers, where the power, nano, 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 they're all nano, they're all 10 to the minus 9. So that means you can focus on looking at the first number, finding the first number. That's the thing that will be different in all of them, but the power is the same. So you don't need to focus then too much about getting the overall power correct. So it depends really on the problem. Some problems, no, some problems they'll give you, one of them is nano, one of them is micro, one of them is whatever. So then you have to do really a detailed, and they might give you the numbers the same, but with the power different. So then you would have to solve it in detail. So you have to really think for each problem, is there something that can make it easier or not? Okay, then a very important thing, this slide explains, let's say you get a bad grade in an exam. How would you systematically try to find out why you got the bad grade and how to improve for the next exam? So after every exam, please keep with you the exam question booklet, the questions, and you put your answers in that question booklet. Sometimes during the exam, if you leave early, you won't be allowed to take the booklet with you, but when the exam is over, you can go back and get it. So you can write your name on the exam question booklet, and then after the exam, you can go and get it. So you can always take your question booklet with you after the exam. When you do that, we're going to post the answer keys to all the problems. So you can always go back and check your answers to figure out which problems you got right and which problems you got wrong. This is very important to have this information. So always keep with you the exam question booklet, and put your answers in it. Of course, you're going to also put your answers in the bubble sheet, but also put it in the question booklet so that you have it with you when you leave the exam, and you can compare with the answer key to see which problems you got wrong. Now, let's say you got a problem wrong. For every problem you got wrong, it's important to try to figure out which category or what was the reason you got it wrong. Was this due to a problem categorizing the problem wrong? Did you not know which part of the chapter or which part of the course this material was talking about? Or was there a problem? Did you make an error in the step-by-step plan to solve the problem? Did you make a correct plan to solve the problem? Or did you make some error in this plan? Or did you, when you made the plan correct, but then you started to substitute with symbols and to find the final solution in symbols, maybe you made a mistake when you were finding the solution in symbols. the final solution. Well, then this is one possible also place where you could have made an error. Okay, or you could have done all those correct, but then you come where you're substituting and getting the numerical calculation and using the calculator, and maybe you made a mistake there. So these four very broad categories, I mean, try to figure out which one of those was the reason that you got the problem wrong. Then you can make a simple plot like this if you want. I mean, it's a nice way to just categorize things. You put each category, this is the first category, second category, third category, fourth category, and then the number of problems that you got wrong because of this issue. In this example, it's 4. The number of problems you got wrong because of this issue is, in this case, 1. The number of problems you got wrong because of this issue, say it's 2. And because of this issue, say it's 6. So why is it nice to make this plot? Because then it can show you what you're getting wrong the most. In this case, this particular student, this is just a hypothetical example, the student is getting 6 problems wrong because of doing the error in the numerical calculation. So he solved the problem correct completely, but then when he comes to substitute the numerical value, he got 6 problems wrong. So then he knows that this student, how to improve for next time, then he should focus on trying to improve the way he does numerical calculations. Practice, just get many problems, try to see how to use the calculator properly, how to use it in an easier way, how to substitute numbers properly, how to simplify the numbers properly. Then you can practice doing that. If you have a problem characterizing the problem, then you know you're doing a mistake in studying for the course. If you have a problem finding the solution in symbols, maybe you have a problem multiplying, dividing, taking common factors, things like that. So if you have a problem finding the step-by-step plan to solve the problem, then you can go back and figure out what was the problem in the plan and how to make the plan better next time. So this is just kind of a guide, because a lot of students ask how to study, how to solve problems in a systematic way, and how to improve if you get a bad grade. This is just an attempt to kind of explain that.